Okay, I believe I am live. Okay, so in the previous live stream, we did Pentagon, and then I left off from there. I will be continuing on for Octagon. So again, a recap was we're gonna try to multiply the apothem by the perimeter, right? And we're given, in this example, we're given the apothem and a side length of the polygon. So let's figure out the area of these regular polygons. To start out, we have an octagon. I already drew a little diagram right here where each side is 50 inches and the apothem, the center to the side, the perpendicular distance from the center to the side is 60.4. So we need to multiply 50 by 8, because there's 8 sides, to get the perimeter of the octagon. So that's 50 times 4, which is 200. And then 200 multiplied by 1/2, because you know the triangles, multiplied by the apothem. So you know our area formula is A is equal to 1/2 perimeter times apothem. So let's go ahead and do that. 200 multiplied by 1/2 multiplied by 60. I wrote it wrong here. This is supposed to be a 60. Okay, so this one will be 200 times 1/2 times 60.4. Yeah, it's a bit confusing, but this is 200. 200 times 1/2 is 100, so we have 100 times 60. 100 times 60.4. Hold on. Oh, oops. Wait a minute. Okay, so it's 50 times 88. It's 50 times 8 because it's a octagon. Sorry about that there. It was a mistake that I said in my previous live stream that I may make mistakes. So we'll just rewrite it. Times 60.4. Then we do 200 times 60.4. And then if you do the math, I'll actually bring up my calculator. 200 times 60.4 is 12,080. We have 12,080 for our octagon. So let me just write that here. 12,080 inches squared. So let's erase this stuff. So we have space. Yeah, we need some space for problem 15. Okay, yeah, I just need to clean this up a little bit. Okay, decagon. I don't think I'm gonna draw a good decagon. It would be, let's see, we'll have like, there's 1 up the top, we'll have 8 and 4 on each side, so it's like, I know, 1, 2, 3, 4. Yeah, I'm not even going to draw it because it's not that good. But we know that we can take this side length and multiply it by how many sides the shape has. So since it's a decagon, it has 10 sides. So since we want to find the perimeter, we'll take 12.3, multiply it by 10. We should get 123. And our apothem is 19, so 123 times 19 would be, hold on, we can just use a calculator in this part because we can on tests and stuff. I'm not saying for everyone, but you could. Okay. So we have 2,337, 2,337, and now we have to multiply that by 1/2, okay, because that's the formula. We would get, let's divide this by 1/2, 1168.5. So I'll actually write that here, 1168.5 meters squared. Okay, now into the hard part. This is all very easy, and I don't even know if I'm gonna have enough space for this. This is why I'm gonna start clearing stuff. Number 17. Before I go on to number 17, I'm gonna check if I have any viewers. No. Let me just send a quick link. And okay, so find the area of each regular polygon. Round your answer to the nearest tenth. So let's actually draw some things on the hexagon, some important information. First information we need, well, we don't really need it. Well, we need it for the formula. So one information we need is the perimeter. When you're given a side length of a shape, you can easily find the perimeter by multiplying 18 by 1, 2, 3, 4, 5, 6. How many sides there are. So let's go and do that. 18 times 6. I can just do that real quick. That's 108. So I'm just going to write here P is equal to 108. Okay, let's remove this. I'll rewrite it if you need to refer back. 18 times 6. Okay? That's 108. Now, we need to find the hypothum. So let's draw a quick little sketch, and you don't need this sketch. I didn't put that much sketches in here, but this is just to show you. We need to find the central angle. Since this is a regular polygon, we can find the central angle of this triangle right here. So the formula is you take 360 and divide it by the number of sides. So we have 6 sides, so we have 60 degrees for this triangle. Okay, so this little part right here is 60 degrees. Okay, and what we want to do to find the apothem is the hypothem is like you take the midpoint of this and you bisect this, okay? I do not know how to make a nice line. I know how to do it. Is this a line? No. I'm just gonna make a regular line right here. Oops, that doesn't look that good. But you get this. These two sides are congruent. And these two sides are also congruent because we're taking the center and the lines in the two-tick are the radii of the hexagon. So we're trying to find, so they're congruent, right? Because all radii are congruent in that polygon. So now let's find our apothem. The way we find this is we can use trigonometry right here. So since this angle, remember, it's bisected, right? So since this angle is bisected, we'll have 30, 30 on each side. So I'm going to erase that so we have space to put 30. Well, 30, and this whole thing is 60 degrees. That means 30, 90, 60. Okay? We do have a 30, 60, 90 triangle, and we can solve it simply, but I'm going to go with the trigonometric way just to get us set on when this angle isn't a nice 30, 60, 90 triangle or a 45, 45, 90, right? Maybe I'll try both ways. Obviously, the 30, 60, 90 triangle is better because it's much easier, but I'll still go with trigonometry for this one. When you're actually doing it, you should probably go with the 30, 60, 90. Anyways, let's start. Okay, so what do we know? Let's take this triangle right here. We know 30, 60, 90. And we also know this side length. This side length is 18, but this one will be 9 because this triangle is split up into two pieces. Okay? And this is the altitude of that triangle. And if you see later on about the altitudes of isosceles triangles, because, you know, two sides are the same, basically you'll get that these two sides are congruent. Anyways, this side length right here is equal to 9 feet. So we know an angle and we know a side length. What do we know? What do we need to know? Let's label this angle X. X is going to be our apothem. Should probably label this A for apothem. So label this A, and we know from 30, we know the opposite, and we know the adjacent. So let's work this out. Opposite over adjacent. What trigonometric function deals with that? Well, tan deals with that. So let's set up a ratio. Tan of 30 is a ratio of the opposite, 9, divided by A. Okay, this is very simple right now. And you can easily, if there's like a invisible divide by 1 here, we can exchange the A, and we have A divided by 1 is equal to 9 divided by tan of 30. So let's go ahead and do that. And you can, instead of just flipping this, you could just multiply by A, and you'll have A times tan 30 is equal to 9, then divide both sides by tan 30. You'll get A is equal to 9 divided by tan 30. You could just simply switch them at the beginning if you know that. Tan 30 Okay, so let's get out our calculator and let's evaluate this. Oh no. Okay, where did my calculator go? 9 divided by, let's put in parentheses just to be safe, 30, 10. Okay, my calculator is a bit different, so it's gonna like put this big number, but I haven't pressed equal sign yet. That's because this is 10 of 30. It's very weird. That's how my calculator works. So 9 divided by this is equal to 15.58 something, okay? And we're not gonna touch that, okay? Because we still need to multiply that times the perimeter. So let's take that multiplied by, actually, let's say the area is equal to the A multiplied by the perimeter. So the perimeter is 18 times 6, which we did up here, which is 108. So let's take that back. Let's bring our calculator back. Okay? Don't forget about it. And we're going to multiply it by 108, which gives us this long decimal, right? Okay, so we have that. And one more thing we need to add. The 1/2. The 1/2. It's basically, 1/2 times perimeter times the apothem. So let's simply divide this by 2. Okay. And we have 841.7766. Yeah. It says round your answer to the nearest tenth. So let's round. Let's just do that. 841 that rounds up to 8 because it rounds up. Feet squared. I'm gonna double check if there's anyone in the chat. Okay, so round our answer, we're gonna go to number 19. Okay, number 19, it's a similar situation, and we want to try to solve for the area of this polygon. So I'm gonna give myself some space right here to work this out. So we know a side length, which is 6 meters, and for our perimeter, let's multiply 6 meters multiplied by 6, which is equal to 36 meters. Okay. So the perimeter of this polygon is 36 meters. Now we have to find our apothem. Let's take the center right here and let's make a triangle. Okay, so we have a triangle and we want to know the apothem, labeled A. I believe this is the same central angle from before because this is a hexagon. So each of the side will be 30, obviously after dividing by 60 degrees, same situation here. And we have another 30, 60, 90 triangle. Now this one, it's basically the same. You would just do the cos, the tangent of 30, you would, let me write it out, the tangent of 30 is equal to 3 divided by A is equal to 3 divided by tan 30. I'm just explaining how we would regularly do it, and then we multiply 36 times the 1/2 times 3 divided by tan 30, and we'll get our answer 18 times 3 tan 30, and we'll do that on the calculator, right? But this time I'm gonna do it a bit different, and I'm just gonna use the 30, 60, 90 triangle, and you'll kind of see why that would be better in this situation. It's not even like, it is helpful, it's easier to solve, but it also gives you an advantage, which I'll show you right here. So 30, 60, 90 is, this is the shortest side, okay, because it's opposite to the shortest angle. That'll be 3, so the hypotenuse has to be 6 because the hypotenuse is double, and the apothem will be 3 times root 3. 3 times root 3. So you have to take the apothem, multiply by 36, multiply by 1/2, we'll get 18 times 3 root 3, get 54 root 3. Now you may be asking, let me first simplify it right here. So because it's asking to round, so 3 root times 54, 93.53. Yeah, I did something wrong here. Oh, actually no, never mind, this is the area. Sorry about that. So 93.5, okay? We got our answer. We could have gotten our answer anyway. So what's the benefit of doing this method? Well, this method simply, it gives you a radical. So if the directions say answer with a radical, or simplify the radical, like right here, actually, another problem. If it says simplest radical form, you can't do that with trigonometry. You need to use 60, 30, 90. Obviously, I don't think they're gonna say to give it in a radical, because you can't really use radicals when trigonometry, at least of what we're being taught. We can only use that long decimal we get and round it off. So that's a benefit of the 30, 60, 90, along with it just regularly easier. Okay. I'm gonna check if anyone is... okay. So, that's okay. Find the area of each regular polygon with the given radius or apothem. If your answer is not an integer, leave it in simplest radical form. Okay, so this is what they mean. This is what they mean by simplest, This is what they mean by simplest radical. This is what I mean. Okay? So, we don't want decimal answer where we round it off. We want a radical. So, let's start. Here we are given the radius of this square, and we want to find the area of this square. So let's get started. This one will be 6. Okay, let's draw a quick apothem. This one is actually pretty easy, I would say, because right here you have a 45, 90, which means you'll have, this will be root 2, this will be 1, root 2, 1, right? So 6 divided by root 2, multiply both sides by root 2. Okay, and we'll get 2 over 6 root 2, which then we'll get 3 root 2 for our apothem. Now, our perimeter would just be 3 root 2 because that's a 45, 90 triangle. So 3 root 2 and 3 root 2. This is just a side length because we want to double it. So this whole side will be 6 root 2. And we multiply that by 1, 2, 3, 4, and we'll get 24 root 2. Multiplied by 3 root 2, which is our apothem. This is P, this is the A, and then multiplied by 1/2. So we can already cancel these two out, and we'll get 24 times 3 times 2 times 1/2. And we could cancel these out to get 72. A nice clean answer. So we have 72 centimeters squared. Okay. Now let's erase this. Actually it's okay, because we're just going down. So 21, go with 23. 23, now we have a hexagon, which means we have to divide the central angle by 6. We have to find the central angle by using the formula, which is 360 divided by 6. That equals 60. This is the same problem we did up here. Not the same problem, but we still have the same shape and the same angles. So this one will be 30 degrees. This one will be 30 degrees. This one will be 60 degrees. Okay, so we can either use knowledge about 30, 60, 90, or we could use trigonometric ratios. For this one, since, in this one I believe we had a side length, and this one we have a radius. I think radius is a bit harder. I'm just gonna go with trigonometric, which is pretty long, but we can do it. So this is A. Okay, this is 6 radical 3. We know the adjacent and we know a hypotenuse. So the correct trigonometric function for that will be cos 30 is equal to A divided by 6 root 3. Okay? We do not like that radical at the bottom, but I think we can stick with that because we're just going to move it to the other side. 6 radical 3 multiplied by cos 30 is equal to the apothem. By the way, this is late, but if you need help on trigonometric ratios, I recently made an animation on that. You can go check that out. But anyways, back to the problem. We're going to do 30. Take the cos of 30. And multiply that by 6. And multiply that by root 3. I didn't press equal sign. No. I should get 9. Wow, what a great answer. What a nice answer we have there. Oh no, hold on. Oh, A is equal to 9, yeah. Okay, so we have 9. There's no fraction. A is equal to 9. Okay, now we need to solve for this bit right here. Okay? So we want to know this bit, which I'm going to label Y. Okay? I like labeling unknown segments with variables. And I have opposite of 30 and the hypotenuse. So let's use sine. Sine of 30 is equal to y divided by 6 radical 3. You multiply both sides by 6 radical 3. You have y is equal to 6. I don't know how we can make this radical 3. Hold on. Is there any way I could... Okay. If you can see that, then that's 6 radical 3. Make a better 6. Oh, just make a better one. 6 radical 3 multiplied by sine 30. Okay. We need our calculator again. So you have 9. We already have that there, so let's keep it that there. And we have 30 sine. Comes out nice. Obviously I'm not using 30, 60, 90, so sine of 30 multiplied by 6 times 3 root, which will give me this long number. Now we can multiply this to get this full side length. Let's multiply this by 2 times 2. That's one side length. And since there are 6 sides to a hexagon, we're going to multiply this by 6. Which would be 62.35. So that would be the perimeter. Perimeter would be give me a second here. Perimeter would be 2y multiplied by 6, which would be 12y. I'm just labeling that as variable. But the actual decimal answer is this. This is 12y. Okay? And I'm going to keep that to the side because I'm going to do P times A times 1/2 for the area. So let's take this, and what I'm actually going to do, it's kind of not practical, but I'm going to just write 6 root 3 times cos 30 all out. Because we may not get to a nice answer like 9 later on. So we have this as our perimeter. We can multiply that by the apothem, which will be times 30 cos equals, and we'll multiply that by 6. We'll multiply that by 3 radical, which gives us this. Okay, so got the mention here. Hold on. Okay. So one of the big parts that I forgot is we have to leave it in simplest radical form. So we have everything right. It's just that we need to actually put this in radical form and leave it like that, not change it to a decimal. Okay? So we'll have 9 times 9 times 12 times 6 would be hold on. Oh. Okay. Okay. So okay. Give me a minute. We have 9 times 12y. Okay, so 12y would be see, here's the parts where it gets stuck. Cos of 30 is equal to x. I'm just double checking my math here. Okay, so I'm gonna work this out. You have our Apothem, multiply that by 12 times y. So we can make we have 72. Oh wait, because this is not distributive, so this would be 72 root 3 multiplied by sine of 30, which should be multiplied by 9. We have 0.5, 0.5 multiplied by 9, which should be 4.5, multiplied by 72, no, that can't be right, that can't be right. Yeah, hold on. It's 9 times 1/2. But we don't have... I'm in a jumble here. What did I do wrong? sine of 30 is equal to y divided by 6 times root 3. Y is equal to 6 root 3 times sine of 30. So sorry about this, guys. But I'm trying to see where this comes from. Oh wait, no, it wasn't that. Oh, hold on. So, if you guys, probably you can't see what I'm looking at, but I kind of, something complicated over here. But that shouldn't lead to an issue. Hopefully. I got x is equal to, a is equal to 9. Yeah, I'm puzzled. I really am. How does that work? I mean, all of these are pretty easy though. I'm using tan. I'm using those ratios. $72 times 12, it would be 72. Oh. It'll be 9 times 32, 36, radical 3. It's 36 times 9. That's not the answer I want. So, I'm gonna see if there's anyone. Okay, so We could do this simple way, but I clearly don't want to do simple way. I'm wasting my time. What's this? Six root three. That's 30. The sine of 30 would be y divided by hypotenuse. Of y times 6 root 3 times sine of 30 should be times 1/2. This should be times y equals. Oh my god. Okay, this is all just me. I'm very sorry for like the 10 years of silence. This is so obvious. It must have been obvious right if you see this video ever again. Okay. So basically, we're gonna multiply this by 1/2. Let's multiply this one by 1/2. So you have 36 root 3 times 9 times sine of 30, which is 1/2. 30 sine, yeah, it's 1/2. So then we can multiply that again and we get 18 root 3 times 9. And we'll get to 18 times 9. 162 root 3. Wow. Okay. Probably for this problem, for all of these problems are either going to be squares, hexagons, or yeah, maybe even triangles, because they have special right triangles embedded within them. Which, if this was a pentagon, or if this was octagon, nonagon, and other odd ones. Actually, any ones that don't give us 16, 30, or 45. We can only leave, basically what I'm saying is we can only leave this in simplest radical form if it's a hexagon, square, or triangle, or some other shape that I don't know. So you have to really think about that one. Okay, so this is the radius. This is also a radius. Radii. The central angle of this would be 120. I'm not gonna draw that out because we're gonna bisect it anyways. So this angle right here is 120. Okay? When we bisect this with the perpendicular apothem, we'll get 60 degrees. 60. Which means we have the 60, 30, 90 right triangle. Just because I want to make it harder on myself, I'm not going to use the easy ratios. And because I use trigonometry. We want to figure out the apothem, which is A. So cos of A, we're using cos of A because we know the adjacent of 60 degrees and the hypotenuse, which is 4. The cos of 60 would be adjacent divided by 4. Not adjacent. Apothem divided by 4. we can multiply both sides. 4 costs 60. And 60 costs, again we got a nice answer, 4 is 2. So apothem is equal to 2. Perimeter. Perimeter is this side, which we are going to label X. Okay? So we want to know this, so opposite and hypotenuse, which is sine. So we can use the sine of 60 is equal to X divided by 4. X is equal to 4 times sine 60. Okay, I'm just double checking because I do not want anything going. I don't think sine of 60 gives anything nice, probably. Okay. So presumably I got 12 and a third. 4, 2, 1. Okay. I think I give up on trigonometry because, well, just have to use the 30, 60, 90. Yeah, that's the easiest way anyway. So, no, this is 2, this is 2 radical 3, 4 radical 3, this whole side, multiply that times 3, we have 12 radical 3, multiplied by 2 times 1/2. Basically, and you have to use special right triangles. You need to know how to use special right triangles, what the special right triangles are, properties of them, to leave it on simplest radical form. So, this answer is cancel out, we're left with 12 radical 3 inches squared. Phew! Anyone watching? Nope. I don't think I'm gonna do those. I think I may be finished. Actually. This one was kind of weird. I actually want to review this. Give me a second again. Oh, these ones are kind of tough. Basically, if this video goes out public, you can put down in the comments below which problem you want done, and I'll probably, maybe, I can do a live stream on that problem. But let's go ahead and do this problem. Let's go with number 15. So number 15, let's draw an altitude. Comes out small. So I'll put it up close. So that's the altitude I want. I have an altitude, and we're gonna try to find the area of this. So how I would do that is, let's call this A, and we have an angle and we have a side length. So we want to figure out opposite and hypotenuse. Opposite hypotenuse that is associated with sine. So sine 33 is equal to A divided by, I'm going to just say that's 5.5. Okay? Gladly, we don't have to do radical. Okay, that might be a good thing or a bad thing, but usually for me it's a good thing. So, we have that. If A is equal to 5.5 times sine of 33, and we have this. We can actually divide this into 2, because 1/2 base times height. We can just take the 1/2 of the base, and we'll get 6 times this. 6 times the altitude. So let's multiply that. 5.5 times 33 sin equals, basically, wait a minute. That is number 15. I had it misplaced. Oh, sorry about that. So that's what A is. We'll multiply times 6. The 17.97, which is basically 18. Area equals 18 feet squared. So to find, the area of this, we're basically dividing this into 2 with an altitude, and we're finding that altitude and using the base. Before, I got a big answer because I actually found the areas of both of these triangles and added them, but this way is so much easier. It'll save a lot of space. Okay, I'll do this one, and okay, so we know the hypotenuse. We want to know this, so the opposite and that hypotenuse, that calls for sine. Sine deals with that. Sine of 28 is equal to opposite divided by hypotenuse. A is equal to 34 multiplied by sine 28, and 39 times A is the area. So let's figure that out. 28 sine times 34 times 34 times 39. Okay? And since this is a triangle, we have to multiply this by 1/2. Let me double check here. We have to multiply. Yeah, so divided by 2, you get 311.25. We have to round to the nearest tenth. That'll be 311.3. 311.3 km squared. Now this one. Oops, that's where did that get me? Okay. Sorry about that. That's not good. Where was I on? Oh. That's not right. I was on 646. Here I was. This, I can form an altitude, right? And I'll label this A. We want to take, hold on, okay, this is 37, okay? This angle right here is 37. Not to get confusing. So the sine of 37, we're using the sine because we know the opposite and hypotenuse. Sine of 37 is equal to the opposite divided by hypotenuse, which is 1, which means A is equal to sine of 37. And we're going to multiply 2.5 times A times 1/2. I included the 1/2 this time. 37 times, 37, take the sine of that, times 2.5 divided by 2. Yeah, we got a weird answer here. We have, if we round it to the tenths, we'll get 0.8 feet squared. Okay, so that's it for what I'm gonna do now. And yeah, so I'll see you guys next time. If you did watch this live stream, you can skip a little bit where I was having troubles with this hexagon, but thanks for watching if you did.